All right, let's start with our vertical asymptote. Vertical asymptote is 1. X equals 1. This time we're looking at horizontal asymptote. Our exponent 2 is greater than 1. What do we know? There is no horizontal asymptote. There is one that is slanted that is called oblique. How do you find the oblique asymptote? You are going to divide. How do you divide x squared minus x minus 2 by x minus 1? What did you say? I would use synthetic division because this is x to the 1 power. 1 goes into 1, -1, -2. 1 times 1 is 1. Bring down the 0. 0, I have a remainder. This was an x squared. This is x plus 0 with this remainder of a -2. What does the line y equals x look like? Y equals mx plus b. I'm going to start at the origin, and I'm going to go up 1, right 1. So it's going to be a slanted line. Now, what is my y-intercept? How do I find y-intercept? Plug in a 0 everywhere there is an x. -2 divided by -1 is 2. Now, what is your x-intercepts? How do you find x-intercepts? Set the numerator equal to 0 and solve. And you can use your quadratic formula. You can factor it, any of those methods that you learned in Algebra 2. Factors of 2 that subtract to give you a -1, -2, and 1. So our zeros are going to be at -1, 0, and 2, 0. These are x-intercepts, so I know that's where it's going to cross my axis. So that one's new. Vertical asymptote is at 1. That's like the last lesson. Horizontal asymptote is slanted. So we're going up 1 over 1, up 1 over 1, up 1 over 1. Use my straight edge here to connect my dots. And I'm connecting these dots with a dotted line because this one is oblique. Now, because of that remainder, when we had that -2 remainder, the graph can cross the oblique asymptote. Okay? So don't just assume it's not. Right here at the center is where it will cross somewhere. But this is called in behavior. The graph is going to approach this line out at infinity and negative infinity. Okay? So -1, 0 tells me I'm above that line. 2, 0 tells me that I'm below those. At 0, 2, I'm at that graph. This one goes beside, curves down, so it's kind of big and wide. And I'm thinking this is probably going to do the same thing. I'm going to try a 3 in there just to make sure that I know what I'm doing. 9 minus 3 minus 2 divided by 3 minus 1 is 2. So it appears to go beside and down. And there's our new graph. Do you want to see another example? Maybe, kind of, sort of. All right. F of x is equal to x squared minus 1 over x minus 2. Start going through the same steps that you did before. What is our vertical asymptote? X equals 2. What is our horizontal asymptote? Well, we don't have a horizontal one because 2 is greater than 1. So we need to find the equation of the oblique asymptote. 1x squared, 0x minus 1, and I'm dividing it by 2. This is 1x plus 2, and here is our remainder of our 3. Y equals x plus 2 is the line in the form of y equals mx plus b. X equals 2. I start at my y-intercept of 0, 2. And I go up 1, right 1, up 1, right 1. And I connect with the dotted line. Now, this y-intercept is the y-intercept for that slanted line. It is not the y-intercept necessarily for our function. So how do I find my y-intercept? This is the equation, y equals x plus 2. The slope is 1. Start at 2, go up 1, right 1, up 1, right 1.
So what do you do with the 3?
Nothing. We're not worried about the 3. It's considered minuscule. To find the y-intercept of our function, we plug a 0 in, and I'm at a positive 1/2, 0 1/2. How do I find my x-intercepts? Take your numerator, and on your test, I'm going to ask you questions specifically on how do you find the y-intercept, how do you find the x-intercepts, what are they? Okay, so you've got to know how to do those. If I set that equal to 0, again, you can solve it in any method that you know how. Factors of 1 that subtract to give you 0 are 0 and 1. I know that it's going to cross at 1, 0 and at negative 1, 0. What I don't know is what happens on the other side of this line, x equals 2. So how do I find that out? Plug in a value. I'm going to start with 3. 3 squared minus 1 over 3 minus 2. 8 over 1 is 8. I plugged in the value of 3 and got an 8. 1, 2, 3, 4, 5, 6, 7, 8. What? It's outside of my graph. Oh no. Here's my horizontal line. And there you go. There's the graph. So don't squish these together. It's going to be way out there.